Ever wondered if we could outsmart Mother Nature and create rain on demand? What if I told you that making rain isn't just a plot from a sci-fi movie, but a reality happening around the world? Stick around until the end, and I'll reveal not just how humans are playing weather gods, but also the unexpected side effects of meddling with nature. Plus, a mind-blowing example of artificial rain you won't believe happened. The process of creating artificial rain, primarily through cloud seeding, involves a series of meticulously planned steps, utilizing specific materials and technologies to induce precipitation. Here's a deep dive into how this fascinating technology operates. The first step involves comprehensive weather analysis to identify potential clouds suitable for seeding. Meteorologists use satellite imagery, radar data, and weather forecasts to select target areas that have clouds with enough moisture but are not naturally precipitating. The core of the artificial rain process lies in selecting the right seeding agents. Silver iodide and sodium chloride are the most commonly used materials. Silver iodide is preferred for its structural similarity to ice, making it effective in cold clouds, while sodium chloride is used for warm clouds. Once selected, these agents are prepared in specific formulations. Silver iodide, for example, is often used in solution with other compounds to enhance its effectiveness. These solutions are then turned into flares or pellets, ready for dispersion. The prepared seeding agents are deployed using aircraft, ground-based generators, or even rockets. Aircraft are equipped with flares that burn the seeding agents, releasing them into the clouds. Ground-based generators, on the other hand, release the agents into the air where they are carried up to the clouds by updrafts. Rockets can also be used to reach higher altitudes quickly. After deployment, the seeded clouds are monitored using radar and satellite technology to observe changes and assess the effectiveness of the seeding. This involves tracking precipitation levels, cloud formation changes, and any immediate weather alterations. The field of artificial rain manufacturing has seen significant technological advancements, enhancing the efficiency and success rates of cloud seeding operations. Drones have emerged as a game changer in cloud seeding. They can fly into clouds that are difficult for manned aircraft to reach, dispersing seeding agents more precisely and safely. Drones are equipped with specialized release mechanisms that accurately deploy the agents at predetermined locations within the clouds. Remote sensing tools, including satellite imagery and radar, are crucial for monitoring cloud formations and identifying the optimal targets for seeding. These technologies provide real-time data on cloud density, altitude, and moisture content, allowing for more strategic planning of seeding operations. The latest ground-based generators are automated and can be remotely controlled to release seeding agents into the atmosphere. This automation allows for timely and precise seeding in response to changing weather conditions, improving the chances of successful rain induction. Artificial rain manufacturing has been deployed across various parts of the world to address water scarcity, improve agricultural productivity, and even mitigate pollution. Here are a few notable examples. One of the most well-documented examples of successful artificial rain creation comes from China, where the Beijing Weather Modification Office regularly uses cloud seeding to increase rainfall. This initiative is part of a broader strategy to combat drought and water scarcity in the region. The efforts have reportedly increased precipitation by billions of cubic meters, significantly benefiting agricultural areas. The UAE, a country characterized by its arid climate, has invested heavily in cloud seeding technology to enhance its water security. The UAE's National Center of Meteorology conducts regular cloud seeding operations, utilizing aircraft to inject clouds with salt crystals to stimulate rain. These efforts have led to a noticeable increase in rainfall, contributing to the replenishment of groundwater reserves and supporting the country's water needs. Initiated by the U.S. Bureau of Reclamation in the 1960s, Project Skywater was one of the early large-scale experiments in weather modification, focused on increasing snowfall in the Rocky Mountains to boost the region's water supply. The project demonstrated the potential of cloud seeding to alter weather patterns, though with varying results. The project laid the groundwork for modern cloud seeding operations in states like California, Utah, and Colorado. While the manufacturing of artificial rain presents a promising solution to water scarcity and agricultural challenges, it also raises significant environmental and ethical concerns. Here's an exploration of these aspects. To mitigate these concerns, ongoing research is essential to better understand the long-term impacts of cloud seeding on weather patterns and ecosystems. Robust regulatory frameworks are also needed to govern the use of artificial rain technologies, ensuring that they are deployed responsibly, ethically, and with minimal environmental impact. As we've explored the intricate process of manufacturing artificial rain, from the initial weather analysis to the deployment of seeding agents, and through to the monitoring of its impact, it's clear that this technology holds significant promise for addressing some of the most pressing environmental challenges of our time, such as water scarcity and agricultural drought. The case studies from around the globe illustrate the practical applications and benefits of artificial rain, demonstrating its potential to enhance water availability and support sustainable agriculture. However, as we venture further into this technological frontier, the environmental and ethical considerations we've discussed underscore the importance of proceeding with caution. The manipulation of weather patterns is not without its risks and complexities, necessitating ongoing research, robust regulatory frameworks, and a commitment to sustainability. Looking ahead, the future of artificial rain manufacturing is bright, driven by technological advancements and a growing recognition of its role in complementing traditional water management strategies. Yet, its success will largely depend on our ability to balance technological innovation with environmental stewardship and ethical responsibility. As we continue to harness the power of science to shape the weather, the story of artificial rain is a testament to human ingenuity and a reminder of our profound connection to the natural world. It's a journey of discovery, innovation, and ultimately, respect for the delicate balance that sustains life on our planet.